Hello, and welcome to the Johnson Controls Blue Water webinar for March 2022. Each monthly webinar is an interactive digital experience for water utilities to learn more about new technologies, software, services, and best practices in a vendor-neutral format. The Blue Water webinar is brought to you by the Water Infrastructure Technology team of Johnson Controls. I am Craig Hanna, and I have the privilege of serving as the engineering manager of this great team. I've been designing projects that reduce both real and apparent water loss, that increase staff efficiency, and that decrease operational and maintenance expenditures for water utilities for the past 20 years. And joining me today are two of my teammates, Audrey, Noel, and Jonathan Gunn. Audrey leads our team from sunny Southern California. Audrey, would you tell us more about how you serve the water industry?
Sure, thanks, Craig. I'm Audrey Noel, and I'm the Business Development Leader for the Water Infrastructure Technology team here at Johnson Controls and directing operations out in the field for years. And coming to me from coast to coast, Jonathan out in New York. Jonathan?
Yeah, thank you, Audrey. A little warmer where you are, although we're hitting 60 today in New York today, so big things. But yeah, thank you. My name is Jonathan Gunn. I'm a market manager with the infrastructure team. I have almost 12 years of experience here in the industry, and like Craig, I serve in a number of different capacities within the American Waterworks Association. So pleasure to be here with you this morning. Thank you for joining us. And to those who are familiar names on the list here, I say welcome back. And to those who may be new or to our webinars, welcome, and we hope you'll find the content to be engaging. And I did want to cover briefly here, for those that may be unfamiliar to the On24 platform, what you're seeing on your screen in front of you here. So you should see some orange dots popping up here as I go through the different components, but obviously the biggest window here is the slide deck. This is where a majority of the action is going to happen. You'll see the slides as we go through the webinar. As poll questions come up, you also answer these in the slide deck. There's one poll question toward the end where you'll see a photo here, and then the poll question will actually pop out in a different window, and you'll understand why when we get to that point. But for all intents and purposes, that's really the majority of the action there. To the top left, you'll see the media player. This is where you currently see my video feed, and you'll see the video feed for the other presenters as we go through the webinar. It's also where you'll see a video that we have later in the webinar. And it's a good time to mention here, too, that all of these windows are movable, scalable. You can move them around, size them to the way you want them, really make it your own. And as a default, when the video comes up later, that media player is supposed to get big, but if for some reason it doesn't, just know that you can move it and you can resize it. Below the media player is the book a meeting function. So if there's something that you hear during the webinar or something you'd like to discuss further, and you feel that an email or something in the Q&A just won't quite do it, please use that function. We'd be happy to talk to you and see how we can help you. To the right of the slide deck is webinar-related content that you can download and read at your leisure. A lot of great content in there that kind of spans a number of webinars that we've done. Then below that is a Q&A box. So we do have a number of occasions during the webinar today where we'll stop and have some Q&A. If something comes up that you want to ask a question, by all means, please use that. And finally, along the bottom, you see the icon bar. There are some icons for some existing windows that you currently see. So if in your moving and resizing you happen to accidentally get rid of one, just go down to the icon bar, click the appropriate icon, and you can get it right back. And then there are some icons further to the right, such as emailing us, earning CU credit, and taking a survey that we ask that you do take a survey at the end. So please utilize that one and take a survey. If you are looking for CU credit, use that. We'll get a certificate to you with all deliberate speed. And then you can obviously email us there as well. And we'll mention the email just a couple times here as well through the webinar. So with that, Craig, do you want to walk us through the agenda for the morning?
Yeah, thank you, Jonathan. We have an exciting and informative webinar for you today. Safety is always a primary concern for us, and we will be starting with a safety talk. And who better to give our safety talk than our good friend, Mr. Dwayne Gillis, who is currently a project manager for Crawford, Murphy & Tilley. Prior to joining that firm, Dwayne spent many years with Evansville Water and Sewer Utility. Dwayne is an AWWA George Warren Fuller Award recipient, and he has served on the AWWA Board of Directors. Following Dwayne's talk, our team will have the first of a two-part in-depth discussion about best practices for large water meter management. Next, Barry Spiegel, Tom Nobis, and Tim Dorr from McCrometer will join us for an interactive discussion about their innovative water meter product line. Now, after the long, cold winter, it's finally time for spring break. How about we all go someplace warm and sunny? I can almost feel the ocean breezes as the saltwater waves wash over me. And we are thrilled to have Mr. Dennis Barron, the Director of Public Works for the City of Jacksonville Beach, Florida, as our special guest. Dennis will tell us more about his water meter and AMI system project with Johnson Controls and how both the water utility and this oceanside community have benefited. And now it gives me great pleasure to introduce to you Mr. Dwayne Gillis. Dwayne, it is a pleasure to have you with us today, and it's so good to see you again. You've had a remarkable career in the water industry. Would you please tell us more about your accomplishments?
Well, thank you, Craig. And yes, I hired in with the Evansville Water Utility in 1972 as a draftsman. The draftsman wore a lot of hats, so I spent a lot of time in the field. And I loved to turn water valves. That was one of my passions, hearing that water go off and hearing it come back on through the valves. And so in 1978, I was promoted to be the maintenance supervisor for the Evansville water system. We had 750 miles of pipeline at that time. And so for 41 years, as through other promotions, I was in charge of that water system until retirement in 2019. That system grew during my tenure from 750 miles of pipeline to over 1,000 miles of water main, and 63,000 services and more than 6,000 fire hydrants. A lot of maintenance in an old system like that. And so this morning I want to talk about safety. I did a lot of safety meetings. I was in charge of safety. As you know, we talked about wearing all those hats, so safety was one of them. I want to talk about how important it is to call 911 before you put a shovel in the ground. 811. So you don't have to call 911 after you do it. So with that, whatever you're doing, you need to call 811 first before you dig, and give them 48 hours to mark those lines. And you don't want to dig, even if for some reason you look out there and some of them aren't marked that you know should be marked. You want to call them back and make sure that they're marked before you dig. Whether it be for water or sewer repairs, or installing a water main or a sewer line or water services, or even if it's just digging in your backyard, you want to call 811. One of the things I'd learned the hard way when we built a house about 26 years ago now, and so I was doing the work, and I had a dozer there, and I was on the dozer, and I had all the utilities marked, but I didn't expect the gas line to be 6 inches deep. And so even though you have all those utilities marked, you do need to check the depths and pothole them because they're at all different depths. And there's also different ways that some of the gas utilities insert half-inch plastic inside their 3/4 or 1-inch iron pipes. And so when you're digging for that, a lot of times you'll find a pipe and you think you've found it, and you continue to dig and you'll hit a live pipe beside of it. Or you think that that's a dead pipe because it's an old iron pipe, and there would be a live pipe inside of it. So those precautions can save you a lot of grief. If you hit a gas line, don't try to repair it yourself. You need to get away from that. Call both 911 and the gas utility at the same time, and get them on the way, and stay safe. And with that, there's all kind of different cables in the ground also, and they're at different depths. sometimes you have, whenever you build a new house, they'll put a telephone drop and they'll just lay it out in your grass, and you can even cut it with a lawnmower. So you need to find that utility and know exactly what you're dealing with. And another thing that I've learned is when your wife points to an area and wants you to plant a rose bush, there's probably a cable right there. So she's the best cable locator that you've got in your household. So with that, we all want to be safe, so call 811 and have your utilities located before you dig. Thank you.
Yeah, thank you, Dwayne. That's such a timely message, because here where I live in Texas, our local utility was doing some work on the sewer lines last Thursday, and they struck a gas line by accident and destroyed the house here where they were working, and damaged several others. And thankfully, no one was hurt, though.
Absolutely. All right. Well, thank you, Dwayne. Appreciate you you going through that safety moment with us. Definitely appreciate that, and all of your contributions to Evans, in the industry over the years. So thank you for being with us, and we'll keep moving here. So we said it before on previous webinars, and I'll say it again today. The JCI water team, we're very passionate about our meters. We do a lot of other things in the water industry, but meters are probably one of our favorite things. And really, this is because water meters are the cash registers for your utility. And for many water utilities, the large water meters specifically, which may only account for a small quantity, maybe 5% of your total population, may generate 30% or more of your overall revenue for your system. We even know of one water utility in Oklahoma that generates 75% of their total revenue from just 2 large water meters in their system. As such, it literally pays to learn all you can about large water meter selection, installation, operation, maintenance, and testing. And as Craig mentioned earlier, today is part 1 of a 2-part series regarding best practices for large water meter management. For this month, we'll focus on large water meter selection and installation, and also as a brief review from last month regarding water meter terminology and sizes. A large water meter is defined as any meter 3 inches in size and larger, or if you have an 1.5 inch or 2-inch turbine or compound type meter, that is also classified as a large meter. As Craig and I mentioned earlier during our introductions, both of us have the unique privilege of serving in a number of different capacities within the American Water Works Association, and that includes serving as co-authors for the AWWA M6 and the M22 manuals. The M6 manual deals with selection, installation, testing, and maintenance practices for water meters, and the M22 deals with the sizing of service lines and sizing of meters. We strongly encourage anyone who is involved with water meters to obtain, both obtain a copy of these 2 manuals and refer to them on a regular basis. If you follow the guidelines found in these 2 manuals, along with the instructions from the manufacturer, you will avoid a problematic installation and maximize billable water and sewer revenue for your utility. We're thrilled to announce that the 4th edition of the M22 manual should be released sometime this year, and we are optimistic that the 6th edition of the M6 manual will be released sometime next year in 2023. By the way, full disclosure here, neither Craig nor myself receive any sort of commission or compensation for any of our work on these manuals. So, we are not getting rich off these. I promise you that. But I know I speak for both of us when I say that both of these manuals were instrumental in both of our careers, especially as we were beginning to learn about the industry. And it's an honor to be able to contribute here years later. So similar to last month, we're not going to take a deep dive into water quality today, as we can fill up an entire webinar just on the effects of meter accuracy on water quality on meter accuracy and useful life. And matter of fact, we're probably going to do that later this year. So, but again, it's certainly something that needs to be considered and is definitely worthy of mention. So for now, let's consider the images on the slide here. The top image on the left side of the screen, you should see a couple orange dots coming in here as I progress, shows debris from an iron pipe that burst and sent various fragments into a 2-inch turbine type water meter and into the measuring chamber. The photo at the right is from another 2-inch horizontal turbine meter, which had stopped registering flow due to a section of iron pipe that was lodged between the impeller and the stator. Thankfully, this meter was tested and found to be accurate and in good condition once it was removed, so it was able to go back in service. But that was a large user that had a zero read there for a while. The image in the center here is of a multi-jet meter measuring chamber assembly, which served as a bypass meter on a dual body compound type meter. All the scale deposits, iron deposits, and sand that had formed around the measuring chamber did so within 4 to 5 years. So needless to say, sand, iron deposits, and hard water were a pretty large problem for that utility. And then finally, the image at the bottom left corner shows an advanced case of tuberculation, which is another problem related to water quality. And it can affect brass and ductile iron meter bodies. So, but again, water quality is certainly not the only thing. There are a number of other factors that go into when you're selecting meters, and it's equally important to understand the types of meters that are available on the market, what their vulnerabilities are, and specifically for larger accounts, how the water will be used at each individual location, so you can select the appropriate type of meter that is best suited for whatever application it is that you're trying to meter. Some larger meters are designed around applications which have consistent high flow rates, while others are designed to be accurate at a wide range of flow rates. Having the correct type of meter in service will maximize billable revenue and minimize apparent water loss. The late George Anderson, for whom the AWWA George Anderson Award for long-term contributions to the field of water metering is named, was well known for saying, quote, "Use compound meters where people live, use turbine meters where people work or play," end quote. Tim Egger has expanded upon that philosophy in his book, The Large Water Meter Handbook. Even though that book was published nearly 30 years ago, it's still remarkably relevant today. Mr. Edgar uses all capital letters to express a key point about large water meter selection. He says that, quote, "The single most common mistake in meter selection is installing a turbine meter in a compound meter application," end quote. In other words, never use a turbine meter, which again is designed for higher, more consistent flow rates, in an application that has most of its usage at lower flow rates. Accuracy at lower flow rates is typically a priority in retail spaces, offices, churches, schools, restaurants, storage facilities, and other light commercial settings. While accuracy at higher flow rates is typically more important and for heavier users such as hospitals, maybe some nursing homes, high-rise apartments, and industrial applications. Irrigation services, swimming pools, and customers with rooftop storage tanks would also fit into kind of this quote-unquote heavier user category for the reason that their consumption pattern is generally an all-or-nothing kind of thing. So there shouldn't be too many low flows happening there. The available large meter types for services with usage mostly at their lower flow rates include traditional compound meters, modified horizontal turbine meters, single jet, ultrasonic, and electromagnetic meters. If you choose a traditional compound meter, make certain that most of the flow does not lie within the crossover range for that meter, since there is a large momentary drop in meter accuracy at that particular range. If the current meter serves both a potable water service and a fire suppression system downstream, the water meter must be either UL listed or FM approved for fire service to ensure that there are no issues in the event of a fire. So I know what you're saying. You're asking me to prove it to you, right? Is it worth the additional time and effort to really sit here and analyze each account and make sure you have the correct type of meter in there? Well, I can firmly say that all of us on the water infrastructure technology team here at Johnson Controls are true believers in selecting the appropriate meter. And that's why we invest so much time and effort, we really do, when we are out surveying, testing, and analyzing each individual large meter that's in our utility customers' distribution system. And really, here's why. For those of you that attended our December webinar, you know that we recently developed a project for a water utility in the Dallas area. The 3-inch turbine meter that you see here serves Walmart. We installed a data logger for 7 consecutive days during a period of normal usage, which is critical. And the meter data logger was programmed for 10-second sampling interval. So we had very, very high resolution data. The maximum recorded flow rate was just shy of 30 gallons per minute, which indicates that the meter is not the correct type for the application, and quite frankly, it's oversized as well. Only 36% of the flow through this 3-inch turbine meter was within the normal range for that meter. A 1-inch meter would have been more than adequate for the service. However, the cost to rework the meter set to accept a smaller meter and the reduction in the base charges that the utility was going to be able to collect with their rate code simply did not make this a practical solution. By changing to a 3-inch ultrasonic meter, however, 90% of the flow is now within the normal range. The meter setting did not have to be reworked, so you avoided some costs there, and the utility did not lose out on the base charges for the account. In fact, the simple payback for this meter was just over 7 months. The combination of having a water meter that was oversized and improperly typed for the application was costing the utility about $4,400 a year in unbilled water and sewer revenue, and that was one customer. Imagine the total benefit to your utility if you have tens or even hundreds of improperly typed or oversized large water meters. So, quick poll question for those out there. How often do you check to see that your utility has the correct size and type of a large water meter installed in each application? Do you have you go out and check fairly frequently? Is it when there's somebody, a new account holder? Do you not have any large water meters? If you want to just take a quick minute and just submit your answer here in the slide deck. Give it about 10, 15 seconds, something like that. So, all right, there we go, 5%. So 18%. Man, we are taking off here. Exponential growth. I like it. All right, I'll give it a 5-second countdown here. Get your answers in. 5, 4, 3, 2, 1. All right. Okay, a nice spread here. Nice spread. So, little mixed bag there. So, no, that's great. Yeah, and it's like I said, it's definitely worth it. So, all right. So, $4,400, man, that's pretty exciting, isn't it? Maybe, potentially $4,400. But, let's not go too overboard just yet and think that every turbine meter in your system is not properly typed. It is important to think logically about which services may be candidates. And since there are still many applications in which most of the flow occurs at intermediate or high flow rates, and, we discussed some examples of that earlier, some of those services, for those applications, a traditional turbine type water meter is very well suited, provided that there's no fire suppression system downstream of the meter. Electromagnetic, ultrasonic, and single jet meters may also be used in these applications, but again, it really depends what you're looking for there. If there is a fire suppression system downstream of the meter, such as a fire hydrant or fire sprinkler system, and the meter also serves potable water usage, select a fire service meter that meets AWWA C703 standards. This simple step will minimize the risk for your utility by providing confirmation that the water meter is designed to provide adequate flow during a fire event. Some large electromagnetic and ultrasonic water meters are also UL listed or FM approved for fire service applications, and a large strainer is not required for those types of meters. Prior to placing an order, we strongly recommend that you confirm with the water meter manufacturer that a particular model is UL listed or FM approved. As a brief aside, a fire line meter is quite different from a fire service meter. A fire line meter is intended only to measure the amount of water used during a fire event. As such, the only usage through a fire line meter should be either during a regular fire sprinkler test or during an actual fire event. Fire line water meters are very expensive to purchase and install, and consequently, not all utilities require fire line meters in their system. For those of you utilities that don't require fire line meters but still have concerns about potential for theft of service on an unmetered line, they may choose to monitor usage by installing a 5/8 inch meter across the test cocks of a single check valve, and that's installed to prevent backflow on the fire line. The 5/8 water meter will not measure all of the flow that can pass through the line, but some of the flow will inevitably make its way through this meter. And so the increase of registration on that meter, the increased consumption, will let the utility know that there's an issue. So another poll question here for you. How does your utility monitor your fire lines? Do you have fire line meters? Do you use the 5/8 meter on a check? Do you do something else? Just let us know here. Give it about 10 seconds or so. Yeah, we're single choice.
Yeah, we're curious to see what your utility does, because I don't know about you, Jonathan, but I see it all over the map.
Yeah, that's my prediction here. All right, there we go. Got a couple coming in here. Yeah. All right, 5 seconds. 5, 4, 3, 2, 1. All right, there we go. Yep, as you predicted, Craig. Definitely a spread there. So some are using the fire alignment. Nobody's using the 5/8, so that's all right. All right. So I did see a couple others there in that response. So yeah, absolutely. You know, it should be noted that there are other solutions out on the market should you not want to put any sort of meter on your fire line. And years ago, we had a utility who needed to know if water was passing through their fire lines, but they were not able to install a fire line meter nor a 5/8 meter on the backflow at those locations. So instead, we utilized a vane flow switch that was both UL listed and FM approved. And the switch would generate a signal if flow is detected, and that signal was integrated into the utility's fixed network AMI system. This allowed the utility to quickly identify where there is an issue and respond accordingly. And last but certainly not least, we do want to mention the importance of production meters. Production meters are often an underrated but absolutely critical component for any water utility. And with so much volume passing through these meters, it's essential that the proper type of meter is selected in order to ensure maximum accountability. Failure to do so will have a domino effect in the future, particularly when trying to accurately calculate water losses in a utility. Some common production meter types include electromagnetic, horizontal turbine, pitot, venturi, and propeller meters. The photo that you see before you is a propeller meter and was installed for one of our customers in Northern California. All right, that was a fairly quick overview regarding some of the considerations that you have to make when you're selecting a large water meter for service. We could probably talk a lot longer than that, but we do have an hour here. So needless to say, selecting the correct meter can be tricky because usage patterns can vary so dramatically from customer to customer when you get to these larger accounts. That said, you know, those of us here, you know, the water infrastructure team, you know, we have a lot of experience in this area, and we're happy to help you make this important decision. So please don't hesitate to book a meeting, submit a question, or reach out to us at bluewater@jci.com. All right, the big question now is, you've gone through the work, you've selected the appropriate meter, you got all your data, you've gone through all that. How do you properly install it? Right? Because what's the point in having the proper meter in there if it's not even installed right? So Audrey, you have just a tremendous amount of experience here. Do you want to talk to us about large water meter installation?
Sure thing, Jonathan. So we talked about the importance of making the time to read and follow the manufacturer's installation guidelines in our webinar last month about best practices for small and intermediate water meters. And that recommendation is equally important when it comes to large water meters. Follow the directions. Here's an example of how not following the manufacturer's guidelines can affect meter accuracy. The pressure reducing valve installed immediately upstream of this compound meter disturbed the flow profile entering the meter, despite the presence of the plate strainer, causing the meter to over-register usage. We tested this meter, and the overall weighted accuracy was 102.4%. Needless to say, the consumer was not too happy when they found this out. Here's another photograph, courtesy of Michael Simpson of the M.E. Simpson Company, and it also serves as a good example of how not following the manufacturer's guidelines can affect meter accuracy. The 90-degree elbow immediately upstream of this compound meter disturbs the flow profile entering the measuring chamber, and the absence of a strainer allows debris to clog the bypass meter measuring chamber. This bypass meter, which registers usage at low flow rates, was clogged with debris and tested at 0% accuracy. The disturbed flow profile entering the main meter caused the meter to be only 16% accurate above the changeover, 68% accurate at the intermediate flow rate, and 75% accurate at the maximum flow rate. The overall weighted average accuracy of this meter is only 25%. At a minimum, every large meter installation must have an inlet valve, an outlet valve, and a test port. We also recommend strainers because it's the best insurance policy you can purchase for a water meter. When properly installed, a strainer will both remove debris from the water and condition the flow for optimal meter accuracy. We recommend strainers for every large water meter installation, including for static water meters. A backflow prevention device is always nice to have and also may be required in some jurisdictions. A bypass line is a highly desirable thing whenever interrupting service could impose a hardship on the account holder. I'm talking about hospitals, nursing homes, apartment complexes, industrial processes that run continuously. If you're concerned about theft of service on a bypass line, we recommend locking the bypass valve. And if that doesn't prevent a theft of service event, cut in a meter in the bypass line, create a new account in your meter data management system, and connect that meter on the bypass line to your AMR or AMI system, and then commence billing for the usage through that bypass line. Always capture the GPS coordinates of the meter setting whenever possible. This is critically important for both AMR and AMI system installations and will save your operations and maintenance teams a ton of time. And don't you just feel for the person who has to replace this water meter set in a crawl space against a wall? First, you need to crawl across a wet floor on your stomach to get past those two set of pipes. You'll also have to drag your tools and the new water meter across that same floor. Then be prepared to spend the next hour or more on your knees changing out this meter. When you've completed that task, you have to drag your tools and the old meter back across the floor and lay back down on that wet floor to crawl out underneath those two sets of pipes. Your meter access cannot be overemphasized. I simply don't understand how this one happened. Why would you choose to install a gate valve in a position in which the operating handle can't be accessed? How are you supposed to ever open or close this gate valve? I've also seen a large water meter with a test port and a vault, but the installer positioned the meter just so that the structure for holding the vault lid was blocking access to the test port. This is a cast-in-place vault that was not very well laid out. As you can see, the outlet flange bolts are cast into the vault wall. Whenever this compound meter is replaced, the corner of that vault will need to be knocked out, and the soil on the other side of the wall will also need to be excavated in order to access the fasteners. And both of these photos show Y-type strainers which have not been properly installed. Y-type strainers depend on gravity to help separate debris from the water, so if they're installed vertically, sideways, or even upside down, they've essentially become a very expensive spool piece and not a great investment of a utility's hard-earned dollars. The drain caulk on a Y strainer is meant for flushing any debris out of the strainer. The drain caulk should not be used as a handy location for a service takeoff. Any debris that the Y strainer removes from the water will now flow directly into this service line. Moreover, you should never install a backflow prevention assembly upstream of a water meter, as shown in this installation. We're very picky about how we install water meters at Johnson Controls. We always specify anti-galling stainless steel nuts and bolts and stainless steel flat washers. Using corrosion-resistant fasteners greatly reduces the risk of fastener failure, and the anti-galling treatment facilitates maintenance and water meter replacement. We'll show you a very scary example of a fastener failure on a large water meter installation in a hotel as part of next month's webinar when we cover best practices for large water meter operations and maintenance. I never quite understood this scenario, but I've seen it at many large water settings throughout the years. The installer will place a smaller meter box and lid inside a somewhat larger water meter box and lid, but the larger water meter box and lid is too small for the meter setting. Consequently, both of these meter boxes will need to be excavated whenever the water meter needs to be repaired or replaced. Why not just select a properly sized meter vault that will allow you unobstructed access to the entire meter setting? This way, your utility will avoid a very costly and time-consuming excavation and then restoration later. Here we see a Saddletype Propeller water meter at a water treatment plant that Dan Hood of the M.E. Simpson Company shared with us. I don't know what is upstream of this water meter, but the water meter manufacturer requires at least one equivalent diameter of straight pipe downstream of the water meter before the installation of concentric reducer. Otherwise, meter accuracy will be compromised. Since this is a production meter and not a revenue meter, that might not seem like a major issue, but remember that the AWWA water audit is a top-down audit, and the volume of water produced is always the first value you enter into that spreadsheet. If the production water meter is inaccurate, which is most likely the case with this meter, the volume of apparent water loss and volume of real water loss that's calculated by the AWWA water audit software will be inaccurate. With a Saddletype Propeller meter, it may be possible to just replace the measuring chamber assembly without removing the wall, but at some point in the future, the entire water meter assembly will need to be replaced, and the portion of the wall that surrounds this water meter will need to be removed and reconstructed. This poorly planned installation will be affecting the utility on its annual water audit and then ultimately lead to a very expensive replacement project. The vault you see here is for a 4-inch water meter at an apartment complex. The vault's in soil and it's surrounded by fir trees. There's no vehicle or foot traffic around the vault. There's no way for anyone to access the meter setting without running a very heavy chain or lifting strap through the 2 meter reading access holes and then lifting the lid with a front end loader or other similar piece of heavy equipment. You can see that 2 corners and mostly one side of the vault lid have already broken away from previous removal attempts. We strongly recommend that vault lids be designed for the appropriate traffic load, that the lid permits safe and easy access to the meter setting, and that the lid minimizes the possibility of creating a confined space hazard for your metering crew. Now, we have a fun challenge for you. There are at least 3 things wrong in this photograph of a 10-inch production water meter setting that came to us from our friend Dan Hood at the Emmy Simpson Company. Let's take a poll about what might be wrong with this setting. So, I'm going to give it a couple minutes here. What are some things that you saw that were wrong with that meter setting?
Yep, this is select as many or as few as you want there, and hopefully you are still seeing the slide. This should be that question I was mentioning earlier that should pop out at you. We'll give you a hint. It's more than one.
Yeah, definitely more than one.
I know our friends at McCrometer are probably crying right now looking at that photo.
Definitely.
Yeah,
All right, I'm
sure
going to go ahead. Go ahead, Jonathan.
Oh, go ahead.
No, I was just going to go ahead and advance it and see if anybody guessed the correct answers here. Oh, wow. We had a lot of people play along.
Yeah. Well done.
John.
Well done.
So, yeah, here are the correct answers. Number 1, there's not enough straight pipe downstream of the 90-degree elbow. Check with the manufacturer, but you typically need a total of 5 equivalent pipe diameters of straight pipe upstream of the meter. A fully open gate valve will count as straight pipe. Number 2, a single check valve bolted to the meter outlet. Again, check with the manufacturer, but you typically need a total of 3 equivalent pipe diameters of straight pipe downstream of the meter. And number 3, never tap the main case of the water meter to install the chlorine injector. Well, that covers our team discussion on best practices for large water meter selection and installation. We'll be covering best practices for large meter operation, maintenance, and testing in our Blue Water webinar next month. We've covered a great amount of material, so please don't be afraid to use the Q&A module to reach out on your console and ask us any additional questions that you may have. Craig, would you mind introducing our special guest for today?
Yeah, I'd be glad to, Audrey. We're so glad to have our friends Barry Spiegel, Tim Dorr, and Tom Nobis from McCrometer with us to talk about their innovative line of large water meters that are used in a variety of applications. And Barry, you are the Director of Sales for Strategic Accounts at McCrometer, and you make your home in Philadelphia. How long have you been with McCrometer?
I've been with McCrometer for 6 years, but I've been in the water business for 35.
Okay, and Tim, you're the Global Sales Development Manager for Municipal Water at McCrometer, and you make your home in Gloucester, England. How long have you been with the company?
Thanks, Craig. Yeah, I'm 6 and a bit years in with McCrometer, but 23 years within the water industry globally.
Excellent. And Tim, we know it's very late in the day in Gloucester, and we especially appreciate you working late to be on the webinar. And Tom, I believe you serve as the Global Sales Development Manager for Industrial at McCrometer, and you make your home in Houston. How long have you been with McCrometer?
Thank you, Craig. I've been with McCrometer for about 10 months, but I've been in instrumentation for 20 plus years for sure. Thanks for
Great.
having us.
We're so glad to have you. And could one of you please tell us when McCrometer was founded and for how many years has McCrometer been making water meters?
Sure. McCrometer was founded in 1955 in Hemet, California, and we're still there. And so obviously we're made in the U.S. and we have 67 years of experience.
Excellent. And all McCrometer water meters are made there in Hemet, California?
Yes.
Excellent. Okay. Well, when people hear the word McCrometer, they often associate it with propeller meters. And we ourselves are about to install a 12-inch propeller meter measuring chamber assembly on a project at a water utility in California. But in addition to your well-known propeller meter line, what other types of water meters do you offer?
Tim, you want to take this one?
Yeah, sure. Thanks, Craig. So we offer a variety of different meters for different applications within both municipal and industrial markets. Mainly our main product lines are full-bore magnetic flow meters, insertion style meters, so single point, as well as our very popular FPI. And then we do also offer differential pressure flow meters, as well as our very popular, of course, propeller meters used extensively across water specialties, etc.
Okay. Well, what is the difference between a single point and a full profile insertion Magmeter?
So, Craig, the main difference between a single point and a full profile or the FPI style flow meter is a single point is measuring the flow in one position. It's either measuring it in the center line or in a 1/8 position of the pipe. So either measuring predominantly at the very top of the pipe. But with an FPI, you're measuring at multiple different velocities across the whole profile of the pipe, measuring all of the flow. So therefore, the accuracy that you can get with a full profile meter is exactly the same as you would expect to get with a full bore style flow meter, but without the need to cut the pipe and install it under flanges, etc. You can install it simply through a tapping at the top and get that same accuracy as you would do with a full bore meter.
Are there any pipe materials that are not suitable for use within an insertion Magmeter?
No, you can use it on any material from concrete to HDPE to MDPE, cast iron, steel, stainless steel. It really is that universal. If you can get a tapping and a saddle on the pipe, then you really can measure any application.
Okay, well, I got to say, I really appreciate your full profile insertion Magmeter. I use it quite frequently, and this meter enables us to leave a large, inaccurate, and/or obsolete water meter in place and avoid the expense, the hazard, and the inconvenience of removing that meter from service. And we found that for the relatively low costs of the McCrometer FPI Magmeter and a saddle tap, we can have a water meter that is 0.5% accurate in the normal flow range across the entire pipe. And what output options are available for a McCrometer Magmeter?
You have the typical standard outputs. Sorry, Tim. The 4-20. You have Modbus. You have Hart. We also have the ability to tie into AMI and AMR systems, as well as some telemetry options.
Excellent, excellent. Well, and what sizes is the FPI meter available?
Anywhere from 4 inches to 138 inches, as you see in this picture.
Wow, 138 inches.
Yeah.
Well, does McCrometer offer a flange spool piece for the FPI Magmeter?
Yes.
Okay, and let's talk about power sources. Can the FPI meter be battery powered?
You have the ability to do AC power, DC power, battery power, and in some cases some solar power.
Okay, and what should one expect for the battery life on the battery pack?
About 5 years, depending on how often you're pulling data.
Okay. Well, can you recommend some uses for the McCrometer FPI Magmeter?
Tim?
Honestly,
Yeah,
you
sure.
can put it
Thanks,
just
Craig.
about anywhere. We have very, very short straight run requirements there. It could go on water mains. Really, anywhere you need to get a solid measurement. There's very few spots where we wouldn't recommend using an FPI. And just to kind of talk about our full profile insertion versus a single point, whenever anyone talks insertion magmeters, they're typically talking about a single point where you're measuring that one single spot. And we are effectively the only company that has this full profile insertion that's 0.5% accurate. I just wanted to make sure that was kind of made clear. We do what no one else can, essentially.
Well, does the FPI need to be recalibrated periodically?
We'd be more than happy to take it back to the factory and charge people to calibrate it. But effectively, magnetic flow meters typically don't need calibration. There's really no drift in that technology. Some municipalities, some regulations require that they are calibrated, perhaps on an annual basis, but it's not a requirement from our side. And we'd be more than happy to do that to make everyone feel comfortable that they're getting an accurate reading, but certainly not necessary.
Okay.
The other
What
thing
about
we have
underground vaults?
available, I'm sorry, Craig, but the other thing we have available is something called Builtin Verification, which is constantly looking at the calibration curve that was set at the factory. And if there's any shift in that curve, you will get an alarm to tell you that something's going on. So then you can further investigate and determine whether it's a meter problem or a system problem or an electrical problem, and then decide what you want to do from there. So it's a really nice feature to have.
Okay. Yes, it is. And I have to ask, is the FPI Magmeter suitable for use in underground vaults?
Yes, submersible or dry.
Okay, yeah, it is. It can be fully submersible then.
Yes, sir.
All right. And McCrometer makes other types of magmeters. What would you like for us to know about the Ultramag product line?
I'll take that one, Craig.
Go ahead, Craig. Tim.
So the Ultramag is quite unique in the market in terms of the type of flow meter it is. In terms of the actual sensor itself, it really has no liner. So there's no rubber liner that's going to delaminate under pressure or actually pull out of the unit. It's actually, the whole sensor itself is covered in the same epoxy 3M ultra liner that we use on the FPI mag, and gives it a very robust coating of the whole instrument. Then we place the electrodes there, but that means that it can cope with quite aggressive different types of fluids. So it's great for wastewater, it's great for effluent products, and also industrial type applications you get on industrial processes. It's a really durable, really easy solution, and it also takes another maintenance issue that we find that our customers have, takes that away from them, so they can install with confidence and know the unit's going to operate for a very long time.
Okay. And I have a question from the audience. They would like for you to briefly explain why not having enough downstream piping can affect meter accuracy.
Yeah, I'll take that on. Depending on what type of meter it is, if you don't have enough downstream piping effect, even though the flow's gone down, you could get a blockage or a re-push back in terms of circulation, in terms of vortices that can actually go back and actually upset the actually flow measurement that's actually going on in front, which is why in the industry we've always talked about the installation in terms of upstream and downstream diameters. Because what you want to try to make sure that although the flow has gone past the instrument, that it's actually made sure that there's no blockage factor or anything vortices coming back in terms of velocities, actually disturbing the flow, which could be just past where the measurement device is. And that could therefore then give you incorrect readings, or even if it's a bidirectional flow meter, actually trying to cause the flow to almost try and reverse, depending, of course, on the flow rate.
All right. Well, thank you very much. And I think we'd like to close with a short video about McCrometer meters. Hopefully it'll show.
made in America since 1955.
All right. If you have any more questions for Tom, Tim, Barry, or our team, please use your Q&A module on the console and ask away. But I'm going to turn it now to Jonathan.
Yeah, thank you, Craig. And I'm actually going to kick it over here to Dennis in a minute here. So we are thrilled to have Dennis Barron. He's the Director of Public Works for the City of Jacksonville Beach, Florida, today as our special guest. You know, for those you may not know, Jacksonville Beach is located on the coast, just east of the city of Jacksonville. And I know had many times I was able to go down there. They tolerated me enough times, I guess. They kept having me back when we were developing a project. And a beautiful area. I definitely enjoyed my time there. And it's always made more special when I get to go someplace warm and nice when I'm here in landlocked upstate New York. So Dennis, good morning, and you know, welcome. Again to the webinar here, and if we may just start out here, could you tell us a little bit about kind of some of your day-to-day and really what makes the city of Jacksonville Beach a great place to live and work?
Yes, thank you. I appreciate it, and I'm really glad to be a part of this Blue Water webinar as well. This has been very informational for me to be able to watch as well and hear the participation. So. You know, Jacksonville Beach was not my first home. Just been here a short time frame now, actually just a little over a couple of years. Come via Central Illinois, so I was able to trade snow and snowstorms and tornadoes for salt and sand, and you know, so far no hurricanes, so I'm not going to complain about that. But yeah, it's been a very good place to work. Fantastic work structure. Same size population I came from, however, significantly more condensed, being on 9 square miles of an island here.
Excellent. Well, and it's yeah, it's a great place down there. And you know, as I said, you touched on it here a second ago about no hurricanes yet. So maybe you haven't had the chance yet, but you know, from what you've heard, you know, I've never been through a hurricane or any of that. Again, being up here in New York, but you know, what, if anything, does the staff have to do to prepare the city of Jax Beach if a tropical storm or hurricane is coming your way?
So, of course, as any time you have to deal with one of these major events, previous and prior planning becomes the huge piece of that. We spend a lot of time in conversation every single year to make sure our plan is active and accurate, and it prepares us for what may be coming. With the events that have happened over the last couple of years with COVID, of course, that changed a lot of things. Where we would normally shelter at particular locations, we had to alter that process and routine because of capacities. And then be ready to, how do we face the community, how do we face the issues and problems that arise post-storm to be able to get people back into their houses and back into their homes. And it literally all comes down to preparation. And it is literally planning to for the worst possible scenario, and being happy when it misses us by a ways. That always makes it a little bit better. And it does an exercise for us. It does. We have everything in place to be able to handle it when it does happen, but at the same time, just happy that we don't have to utilize that on an ongoing basis.
Yep, absolutely. All right. Great. Well, you know, not to get selfish here, but I mean, you know, what were some of the issues and challenges you were facing that really prompted the city of Jax Beach to develop a meter? And we did electric meters, a few natural gas meters as well, along with the fixed network AMI system. You know, what were some of the challenges that led to that decision?
So this project was underway, obviously, when I came in. We're in year 4, and of course, I've only been here 2 years, so it was already underway in the process. But our previous meters were still manual read. We still had a lot of intensive manpower to go around and read those on a monthly basis, to be able to handle the billing, to be able to rely on Johnson Controls to help us move ahead to the AMI system has been fantastic. My history as previous was in water as well, and it was with an AMR system, which still required a significant amount of labor to be able to go around and collect that data and collect those meter reads every month. And the AMI system ourselves has been fantastic for being able to to collect that data remotely, as well as to be able to look deeper dive into the actual meters and what may or may not be going on for a particular issue, so that when we have concerns from our customers, we're able to address those significantly faster and more thoroughly.
Okay. And is some of what you mentioned there, I mean, do you think that was part of the reason why Jacksonville Beach went with a fixed network AMI solution versus a mobile network?
I believe so. I mean, 100%. 9 square miles, it's really easy to manage and maintain, ensure that you don't have any dead spots within your area. We were able to create a network, that had some resiliency built into it from the beginning. So we have more ability than what we're actually utilizing, so that in the event of something going down, we have the ability to be able to tap into additional towers to be able to get that data and keep that flow consistent. And I know we're looking into additional AMR or AMI type tie-ins to be able to monitor remotely some additional information and data that we want to collect in the event of a storm where we have to relocate, so that we can still kind of keep an eye on what's going on, even though we may not be here.
Excellent. Yeah, that's one of the great things there, right? Push of a button kind of stuff, right?
Exactly.
So, what were some of the, I mean, you kind of came in midstream there, but, as you observed the project being installed, what were some processes and procedures that had to be changed or modified as you were migrating from that manual system to the AMI network?
Other than just the actual, inner workings of the meter system itself, our utility billing department had to do a lot of different training and additional keys to be able to utilize that information and be able to help customers based on their questions and answers. And I know for us, one of the big pushes that we've seen here as we're continuing to monitor and review this system is the system is outperforming the expectations. We're seeing 99% accuracy still into year 4. We're doing random residential meter testing and replacement, as well as more frequently annual larger meter testing to be able to assure, and we're seeing those results come in with very high accuracy, actually higher than what was expected or promised. So that's a very good thing for us to be able to keep an accurate pulse on what our actual water usage is and where.
Excellent. Yeah, that's what we like to hear, right? we don't want to share. So, what's that?
I said you got it for 100% with that.
Okay. All right. So I guess if I just kind of a final thing here. I mean, how would you say overall? I think you've really hit a number of points here, but overall, how would you say the utility has benefited, the citizens of Jax Beach have benefited, and are there any points of advice that you might have for utilities that are facing some of those similar challenges and just getting their system up to grade?
I think the biggest piece of advice I could answer to that is to make sure you're getting involved with what you really want or need. Don't consider, and this is a large investment to be able to do something like this to a utility, and you have to be concerned about what your deliverables are going to be, and don't shortcut things in the beginning stages where you have the opportunity to be able to get a more robust system, especially when it comes to the AMI system over an AMR system versus a manual read system. I mean, when you can get into the opportunity to help automate that and be able to get that data and then help to transfer that to your customer, that helps provide some of the best customer service that you can provide to your customers, to your water users, and to your commercial businesses as well that are out there that, everybody knows what we faced over the last couple of years, and they're all concerned with expenses. And this is one of those that we can assure that you're receiving an accurate bill for what you're actually utilizing, and there's not any issues or problems with our system that could lead to, overbilling or problems and concerns.
Absolutely. Yeah, I think you hit it on the head there. Accountability is probably number one, right? Priority. High, low. It's you don't want to get surprised, and you also don't want to get overbilled. So awesome. Well, Dennis, I again can't thank you enough for being here with us this morning and taking some time out of your day. And hopefully it's not raining there today. I know it was last time we spoke, so hopefully a little more sunshine there. We got the rain up here.
Yeah, I know. Unfortunately, it's 80 and sunny and bright, just like you would expect any other time in Florida. So we definitely have a beautiful day in front of us today. So nothing wrong with that.
I'm buying my ticket now.
Come on.
All right. Thanks again, Dennis. We appreciate you.
Thank you. I appreciate the invitation.
So, all right. So with that, I do want to thank everyone for joining us today. Again, if there are any follow-up questions, or I know we're at the top of the hour here, so if there are any follow-up questions or anything you'd like to know more about, obviously please either submit a question through the Q&A while we're still live here, send us an email, or book a meeting with us. Our next Blue Water webinar is just over a month from now here, April 20th. And that will be obviously part 2 of our best practices for large water meter management. Badger Meter will be our industry partner on that webinar, and you can see the link there on your screen. Unfortunately, it's not live, but you can either screenshot it or refer to it later, write it down, whatever. There will also be communication coming out as well on how you can register for that webinar. I do want to say, again, a very special thank you to our guests this morning, Dwayne, Barry, Tom, Tim, and Dennis for being with us this morning. Just some phenomenal advice, some phenomenal expertise and experience on the call this morning. So we want to thank you all for being with us this morning. And with that, again, thank you for attending our webinar. We hope to see you in April. And again, please utilize those features on your screen. Take a survey for us. Let us know how we did, anything we can do to improve. And obviously, any questions, please submit those in the ways I outlined earlier. So thank you for being here so long, and we'll hope to see you next month. Take care.
Yeah, thank you.